All right, so it froze the last time I was making my video, so I'm picking up right here where I left off. So here we go. So we were talking about what range of values can a triangle with the following sides have for its third side. So I told you that we have sides 4 and 6. So what could that third side be? Anything that's a little more than 2 but less than 10. So in my visual here, right, I drew it out so we can see that it has to be just a little bit more than the difference between the two known sides, so a little bit more than 2, but it has to be also a little less than the sum of the two known sides, so it has to be a little less than 10. Okay, remember that this is our visual anchor right here. I'm going to put my finger right there. Picture that as the vertex of the angle, and I know that I could really open up, right, I can make a third side here, 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 right? Various locations between those two extremes, the difference and the sum. All right, so moving on to example 6. Which of the following are possible side lengths of a triangle? State possible or not possible. So what we're doing here is we're taking this part of the triangle inequality theorem. We're looking at C, and is it less than the sum of the other two sides? So if we can get a true statement here, we know it's a possible triangle. If we get a false statement, it is not possible. So first one here, I see this is my biggest side. That's what C is. Is 7 less than 3 plus 4? Is 7 less than itself? Right? Clearly that is false. That is a false statement, right? Which tells us it is not possible. Okay, and if we visualize that, let me draw the longest side here as 7. If my other two sides are 3 and 4, it would just make a straight pathway just like so. It would not produce a triangle. Okay, in the next one here, I'm saying, well, what if the largest side is 10? So here we go, 10. Is 10 less than 3 plus 4? Is 10 less than 7? Right, also false, still not possible. Okay, if I draw myself a visual here, here's my largest side, 10, and those two little sweet sides of 3 and 4, they're just too short. They're just too small to be able to connect and make a triangle. Not possible. Okay, last scenario here, biggest side is 5. Is 5 less than the sum of 3 and 4? Yes, 5 is less than 7. Finally, we got one that is true. And that tells us that this triangle would be possible. And I'm hopeful that we can recognize this as the most common Pythagorean triple as well. So here's my side that's 5, here's 3, here's 4, right? We know that those are common sides of a right triangle. It's our most common Pythagorean triple. All right, next up, example 7. So if I give you 3 sides of a triangle, can you classify it as acute, right, obtuse? So that's classifying by angle. And then can you classify further by side, equilateral, isosceles, or scalene? So right now here, I'm giving you 3 sides. I'm giving you 3 root 2, 2 root 5, and 6. And here I'm giving you just a little reminder as to when it's going to be right, acute, or obtuse. So again, a little recap from last semester. So here we're doing a play on the Pythagorean theorem. We're saying, well, if I look at that largest side squared, c squared, how does it relate to a squared plus b squared? So if I look here, a right triangle, well, that means I should see an equal sign here. C squared should be equal to a squared plus b squared. Okay, but if it's acute, I'm looking at this angle right here with C, the largest side opposite. Right here I'm looking at, well, what would change if this angle now is less than 90, right? All of these angles would be less than 90 to be acute. So here I can see that, well, that C squared would have to be less than the sum of A squared plus B squared. That would make it acute. Okay, and then lastly, obtuse. So I'm looking at this angle opposite here, my biggest side. So here's that vertex of this angle right here, more than 90 degrees. So what makes this one different is that C squared would be greater than A squared plus B squared. All right, so again, just a little refresher on how we can classify by angle. So it's either right, acute, or obtuse. So we're looking at that largest side squared and how it relates to the A squared plus B squared values. All right, so let's look at our problem here. I have three sides given, 3 root 2, 2 root 5, and 6. And I might not see which one is my biggest side because I see all of those radicals. So it might help just to square each side first and see which one is going to give me the biggest number. So I'm looking at all 3 sides and I'm just going to square them right off the bat. So first, 3 root 2 as a quantity squared is like saying 3 times 3 times 2, and that gets me 18. 2 root 5 squared is like saying 2 times 2 times 5, or 20. And 6 squared, 6 times 6 is 36. Okay, so if I go to this structure then, C squared, how does it relate to A squared plus B squared? Well, my C squared has to be the 6 squared to get 36. So again, just write out that structure. C squared, and then a little gap, A squared plus B squared. So C squared, I know it's 36. How does that relate to 18 plus 20? How does 36 relate to 38? Well, it's less than 38, so that tells me that it's this variation right here. It must be acute. All of the angle measures have to be less than 90. This biggest angle measure here has to be less than 90. It's opposite that biggest side of C right here. Okay, and then if I look at my sides, all 3 sides are different. So it's acute and scalene. Isosceles means 2 or more congruent sides, and equilateral means all 3 are congruent. We know that equilateral triangles are also isosceles. All right, next up, example 8. So here a triangle has the following side measures. We're given 4 and 6. We want to find all possible measures for the third side if the triangle is isosceles. Okay, so if it's isosceles, that means that we have 2 congruent sides, at least 2 congruent sides, but we're told that we concretely know 2 measures. One is 4 and one is 6. So we really have 2 options for what that third side could be if it's isosceles. So it could be that 4 represents a leg, which means that the other leg would be 4, and then the base would be 6. That would be an option. Or it could be that 6 is a leg, which means the other leg is 6, and then the base would be 4. So that third side could be 4 or 6. Okay, well, what if the triangle is right? Let me draw a right triangle for an example. So let's say my 2 sides are 4 and 6. Well, those 2 sides could be the legs, for example, 4 and 6, and I could be solving for the hypotenuse. So if that's the case, then I'm using Pythagorean Theorem. My 2 legs are the A and the B. So I'm looking at 4 squared, so 16. 6 squared is 36, and then x squared. So x squared is 52. Take the square root. Okay, 52 is 4 times 13. So 2 root 13 plus or minus. Okay, we know it has to be positive because it's a side length, but I'll address that in just a moment. Okay, what would be my other option if my triangle is right? Let me just draw myself another visual anchor. So it could be that I'm given a leg and a hypotenuse. So if I have one leg, one hypotenuse, my hypotenuse has to be the bigger of the two. My hypotenuse is the largest side in any right triangle. So the 6 would have to be here, and the 4, right, it just has to be a leg, and then I'm solving for the other leg. So Pythagorean theorem one more time, but we're solving for a leg. 4 squared plus x squared equals 6 squared. So 16 plus x squared equals 36. Take away the 16, x squared equals 20. Okay, take that square root. 20 is 4 times 5, so plus or minus 2 root 5. Okay, now again, since it has to be a side measure, we're really looking only at the positive. So that third side, if it's a hypotenuse, it would be 2 root 13. But if it was a leg, it would be 2 root 5. No other option for the right triangle. All right, next, solve for x, then find the area of each right triangle. If we see any radicals, we are supposed to simplify. Okay, so I'm seeing some variables. So if I want to solve for x, I'm still using the Pythagorean theorem. So I know that x squared plus 2x as a quantity squared equals 10 squared. So I have x squared plus 2x times itself is 4x squared, right? It's like saying 2x times 2x, right? That's 4x squared, and that gets me to 100. Okay, add together, and we have 5x squared equals 100. Divide by 5. X squared equals 20. Solve by taking the square root, and x would be plus or minus 2 root 5. But again, it has to be the positive. It represents a side length, so x has to be positive 2 root 5. This side right here would be 2 root 5. This side right here, this longer of the two legs, 2 times 2 root 5 is 4 root 5. All right, so I know x, I know what each side length is, and now I want area. So area is half the base times the height. When it's a right triangle, we love it, has to be the two legs. So I'm saying half of 2 root 5 times 4 root 5. So half of 2 times 4 times 5. Half of 2 is 1 times 4 times 5, and we're at 20. So 20 units squared. All right, one more. Same idea right here in B. So I see it's a right triangle. I'm using Pythagorean theorem first to get to x. So I know that x plus 2 squared plus x minus 1 squared equals the square root of 65 squared. Okay, and then here I'm just going to multiply these out. Hey Scar, I'm just making a video really quickly. You want to come up here and wait?
Mommy, no, told you are done with 4.
Okay.
And Andy, watch this from Brody. The way he fizzes in your mouth.
Oh, let's see. Okay.
The way he fizzes in your mouth.
Okay. Can you sit here so I can finish up this last video for just a
Yeah,
minute?
Mama.
Yeah? Can you say, hi everyone?
Mama, eat this.
Thank you, honey. Oh, okay. Well, I'm just making my last video. Can you wait for me for just a couple minutes?
Yes, sir.
Okay, thank you, sweetie.
And I like to watch you eat
You
it.
want to watch me eat it, but I'm making a video. Okay. All right, here we go. All right, so I have to FOIL this out. So when I FOIL it out, I have x squared plus 2x plus 2x
Hey, I can see your hand.
plus 4 is my hand. You're not silly?
Yeah, that's silly.
Okay, FOIL out that second part. So I have x squared minus x plus 1, all equal to 65. All right, I got my 3-year-old here. She's ready for me to be
Mommy,
done.
did you
So
like
let
it?
me quickly consolidate. I love it, honey. It's great. I'll be done in 1 minute. All right, so consolidate the like terms, and I have 2x squared plus 2x plus 5 equals 65. Okay, take away that 65 from each side. We should see it's a quadratic. We want to solve by factoring. Okay, right now I have 2x squared plus 2x minus 60. Pull out that GCF. So I have 2 times x squared plus x minus 30, all equal to 0. Okay, factor it down. What multiplies to negative 30 that adds to 1? And I get x plus 6 and x minus 5. All right, my 2 solutions, I could get negative 6, I could get positive 5. Okay, however, negative 6 is not going to work. If I tried to plug it back in here or here, it would give me something negative. I can't have a negative side measure, so that solution is out. It's got to be the 5. Okay, and then if I get the area, 1/2 base times height. If I plug that 5 back in, this side is 7, this side is 4. So half of 7 times 4. Probably do half of 4 first because it's even. So 2 and then times 7 is 14. So total area is 14 units squared. All right, that's all I got for today. Thank you for bearing with me when Scarlett came into the room. All right, have a good rest of your day.